Today we will be talking about data center migration, and specifically we will talk about EVPN and VXLAN, then how they use during the migration process different data centers, during the migration process Ansible for automation as well. So we will deep dive. Who is with me? Anuj?
Hi guys, my name is Anuj Ladkani. I'm a network engineer like you guys. I'm in the CCD group with Orhan for a little bit now. And I noticed that various engineers were sharing whatever they have learned in their environments. And I felt like because of the recent opportunities that I got with EVPN VXLAN and the use of automation and some interesting projects in general, I felt like I can share to the community too. And that's when we decided to do a session like this, and today we are doing it.
Thanks for that, Anuj. So, Anuj, please explain what we are seeing at the moment. We have different data centers, yeah, I think. Go ahead.
Yeah, I'll stop my camera so that I get the proper bandwidth for the audio.
Sure.
And then I'll start sharing the material.
We didn't.
So
I would like to.
A little bit of background on what I'm going to talk about. So a year back, if you would have reached out to me, I had no idea about what EVPN VXLAN would do. And EVPN is a big protocol suite like MPLS. So even now, I do not have idea about every single feature, but I got opportunity to deploy a brand new data center using EVPN VXLAN, which was going to be a disaster recovery data center for my employer. And we had various production DCs, which are now going to use the DC that I worked on deployed, which is now live since mid last year. And towards the end of that project, I then got another project where we suddenly had a requirement where one of our smaller DCs for a certain business reason was going to be shut down, and we had to do a migration to an existing DC. So there was nothing greenfield about it. But whatever lessons I learned with the first greenfield deploy, it to me felt like EVPN VXLAN is a good tool to help with the migration because we did not have option to shut down our applications. The requirement was to migrate while the customers are using our product. So it was an active migration. That migration is still going on, by the way, and it will be done in a couple of months. It's on track. Now, when I did the Greenfield deploy, the first time when I used EVPN VXLAN, I did not design the architecture of what will be used and whether we will use distributed EVPN VXLAN routing or centralized and what kind of gear and requirements. That was done by an architect in my group who left start of last year, and that's how I was thrown into the project. So because of that reason, this presentation, I will start by talking about the second project first, because that was purely my design, and I can take the credit of talking about it. And then towards the end, after talking a little bit about automation, I will talk about the Greenfield deploy also, and then we can go to questions.
Okay, fine. So now, what I understood is we will be talking from one data center to another data center migration, and applications will move from one data center to another, right?
That is correct. So we are going to start talking about that. So if you guys can still see my screen, okay, this was the scenario that was given to me one day suddenly by our management. So we have this on the right side, this data center one, which was a mid-sized data center. It had like multiple ISPs, 10 gig in and out of internet traffic, good amount of east-west traffic happening. And I was told that this data center in 6 months has to be shut down, and we want to migrate our servers, our storage, our databases, application, the whole thing in an uptime fashion to this data center 2 that you see on the left side. So the data center that we are migrating to, it's not a greenfield deploy. It's not like I can architect everything from scratch and do things to the best of the possibility. I have to work with the constraints that both the data centers have live traffic. So this is not some POC, some R&D lab. This is live data centers giving revenue with active customers, and the task is to seamlessly migrate things from the data center 1, which you see on the right, to the left. So this was the context of the problem given to me.
Okay.
I'll talk a little bit about the details of how these data centers were. So the data center that I had to shut down was a multi-vendor. The cores were one vendor. They were doing MCLAG. They are still doing MCLAG. Like I said, the migration is still ongoing. Neither of these data centers was doing EVPN VXLAN at the start of the migration. So you have the traditional core, which is with the use of Peerlink. It's doing VPC/MCLAG. The edge routers were different vendor, Juniper in this case, and we had multiple ISPs, so classic EBGP there, and stuff that people are familiar with. I had OSPF area 0 from the core to the edge for all the public routes, so the edge can get it and then advertise it to the internet. And core is where all the layer 3 was, so that's where all the SVIs are. And then I had a bunch of distribution, and some of the distribution were in pairs capable of doing MCLAG down towards the TOR, and some distributions were not MCLAG capable, and they were using spanning tree and whatever else down towards the top of the rack. Top of the rack again was a combination of multiple vendors, because this is your classic old school data center where things were added as needed over a period of time. So it was not a monolithic architecture with all one vendor, whatever big vendor names we know of.
Okay.
So this is the data center in hand, which has lots of servers, lots of storage, databases, mail forms, application forms, web servers that has to be migrated.
Okay.
This data center
Anuj,
already
Anuj, can you hear me? So far, we understood what we had in the DC1, but we didn't ask the question we should ask in the first place. What was the reason they are shutting down this DC1? Why?
Because I'm an engineer and not in management position, without giving too many details,
sure,
it had to do with certain requirements from the business. I would say if you guys can accept that as an answer, but the reasons were big enough that we had to close it in a timely fashion.
Not a technical reason, it seems business decision, but not a technical reason. Maybe it is costly, etc.
Yes.
Okay, fine.
So the part that I was going to talk about is, so this existing data center 1 on the right side already have wave circuits for east-west traffic between the two data centers, because we were doing things like database backups, replication between storage, things like NetApp SnapMirror, if people are familiar with that. But we had wave circuits for that east-west traffic. Now, these wave circuits were not, for example, these were like bunch of 10 gigs, right? But they were not big enough to do the kind of migration bandwidth that we would require to do the migration, do that much traffic. So we beefed that up, and I will talk a little bit about that. But that's a small logistic feature to keep in mind, that we had the option to beef up this point-to-point link from a redundancy, from the amount of bandwidth point of view, so that we can successfully do the migration. So now let's talk about the data center that we are going to migrate it to before the migration was planned and before it started. Again, it was similar to the data center that we are shutting down, old school core devices. That's where all the layer 3 was. That was capable of doing VPC/MCLAG. Distribution, again, similar functionality. What you do not see in the diagram is the fact that there were multiple physical cages involved in the data center. In fact, multiple physical floors involved. I did not draw that because it's a logistics that we had to take care of and the constraint that we had to be aware of, but it's not super important from a logical diagram. But keep that in mind, that there were multiple physical cages and connectivity between the cages involved, because I'm going to talk briefly about that in one of the constraints in the later diagrams. So same architecture, cores and edge were doing OSPF, and then edge outwards was multiple ISPs.
By the way,
one good aspect here was that.
By the way,
go ahead, Orhan.
You are migrating by connecting physically core device to core device, right?
This, like I said, this wave circuit was already there with for east-west traffic between the two data centers. And now for the migration, I will use this layer 3 connectivity between the two data centers to run my EVPN fabric on top of it.
Yes,
This will become my underlay,
but
and I will talk about
that wave circuit layer 3 connectivity between the core devices, physically core devices, right? Not distribution
that
to
is
distribution,
correct.
etc. Okay.
It is physically on the core devices. That is correct.
Okay.
Another thing to keep in mind is there was no IGP. Like I do not show any IGP between the data centers. We only had static routes, and we will continue to do only static routes between them. The IGP was local to each data center, so we did not have a common IGP between them. Another technical aspect that I would like to share, it did not matter too much, but still it is part of the larger logistics, is both the data centers were using common ASN towards the internet. So because it was like similar business, my company has a lot of ASNs, but in this case, both the data centers were using same public ASN. So this was the initial layout. This was the ask. What I decided to do along with others in my team, and as I now talk about the steps I took to prepare for the migration and the end design, I'm not going to draw every single box you see in the previous diagram. I will only draw the relevant pictures. So now, let's focus on the right side, which is the data center one. You have the same core devices that you saw earlier. I'm not showing TORs anymore. I'm not showing edge anymore because it's there. Nothing has changed. And different here is I added two layer 2 gateway capable routers south of the core, and I did back-to-back MC lag on them. So the core, like I said, was VPC capable. So it is doing a layer 2 VPC towards this layer L2 gateway router. And the L2 gateway router, because this is EVPN, I was doing an ESI towards the core. But look at it like a back-to-back VPC. It's not so much important that one side the VPC was using ESI to do the multi-chassis functionality, and the other side was using MLAG, MCLAG, or VPC. That doesn't matter. So I made them layer 2 connected, like you see in the diagram. And I also put links between the layer 2 gateway router and the core router in the data center on the right side with layer 3 links. Now, this layer 3 link is important because that is what is going to connect. These layer 2 gateway routers are our VTEPs, and this layer 3 connectivity is what is going to provide the underlay for the data center migration. Let us look at the diagram on the left side, which is the data center where we are migrating data center 1. So for all intents and purposes, data center 1 will become a tenant in data center 2. So we installed two new these routers here, which are L3 gateway capable, so they can do VXLAN routing and bridging, and they are connected to the existing core in data center 1. And links between them were layer 3. There was no reason to put layer 2 there, because now it is all EVPN fabric. And then we had to add a bunch of distribution here. These distribution switches I had to add because if you guys remember, I said that the data center that we are migrating to has multiple cages, multiple floors involved. So because multiple floors were involved and I had constraints on how many fiber runs, duplex fiber we can do, I had to put distribution layer so that all these stores that I will connect to them, they can terminate on the distribution, and the distribution can then use bi-die optics is what we use. So they can use 40 gigs each going to this new core that I installed. And from this new core to the existing core, this was all 40 gigs. And my existing core in DC2 was a Cisco 9032PQ. It was capable of doing 40 gigs there. So I was able to do 40 gigs for all the important endpoints that mattered. So this distribution device that you see is not participating in EVPN at all. It's just aggregation device for port density reasons, for optic form factor reasons, and it is only doing OSPF. And I'll talk about OSPF changes in a minute. And these stores are layer 2 gateway capable, which means they are our VTEPs, and they will have VXLAN bridging capabilities. And this router here could do VXLAN bridging and routing.
Okay.
Now
Anuj, at the moment, let me ask a couple questions for clarification. Here in DC1 as well as in DC2, we have layer 2 gateway devices. So in DC1, we didn't have those devices before the migration at all. We just now we are adding it, and the reason for that, we will start EVPN from those devices, right?
That is correct.
Okay.
So these layer 2 gateway devices that you see on one, they are going to inject all the MAC addresses that are present in DC1 and make them as type 2 routes, which if people are familiar with EVPN, multiple type 1, type 2, type 3, and so on. But the type 2 routes are your MAC and the IP mapping routes. They will inject those routes into EVPN fabric, and that is how we will do the migration, so that when we migrate things to DC2 on the left, they will still be able to be part of that layer 2 domain, so to speak.
Okay. And DC2 top of rack L2 gateway devices, they are your just regular top of rack devices. You are not adding new Tor devices there, right?
No, that is incorrect. So the Tor devices on the data center 2, these are also newly provisioned Tors, which are VXLAN, EVPN capable. It's just that they are not capable of VXLAN routing. They are only capable of VXLAN bridging, like these two devices here. So these Tors are also brand new. This distribution is brand new, and even this core is new.
Okay, cool.
The tenant core, let's call it the tenant core, and this is the existing core. So the tenant core is capable of VXLAN routing and bridging, because that is where we will migrate the entire layer 3 to from DC1 that we are shutting down. And this Tor is also EVPN VXLAN capable. It's just that it cannot do VXLAN routing, and there wasn't a need for it to do VXLAN routing. So these are also new Tors.
Will you remove these devices after the migration?
We will not remove these devices after the migration. The data center 1 that we are shutting down will be permanently on EVPN VXLAN on a separate fabric, which I said for all intents and purposes will be like a tenant in data center 2. So you can think of it like a customer of data center 2, which will be on a separate EVPN fabric, and it will only use these layer 3 links to go north-south from an internet point of view, and they will take this double dip for any east-west traffic for anything existing in data center 2 that needs to talk to this migrated data center 1 locally here.
Okay.
So let's talk a little bit about the OSPF changes that I had to do, and there are various ways to do this. Disclaimer, all the EVPN devices that I used are Juniper in this case, and Juniper is not forcing me and others to go with what people normally think is they are forcing everyone to do eBGP underlay and IBGP overlay. There isn't such a requirement. Like you see here, I did OSPF, and I'll talk about it. OSPF was my underlay, and then I did IBGP with route reflector servers. So these DC1, DC2 new, DC1 core 1 new and core 2 new, they are the RRs, both of them different cluster IDs and regular IBGP session between them. We'll talk about that in a bit. But OSPF was the underlay, and then I did IBGP on top of it for the EVPN family NLRIs. So really fancy on the OSPF. So these layer 3 links on data center 1, I made them part of a new OSPF area. I made it TNSSA because they only need to get a default route to go to the core. And the same thing here, a new OSPF area, TNSSA again, and they will get the default from the existing core. The core already had a default route from the edge routers, and we are getting full table from our ISPs. And these TNSSA areas, as I move the layer 3 on them, so the SVIs on the data center, existing data center that we are shutting down, will be moved on these new routers that are routers. They will advertise them as members of this TNSSA area. That's how the core in DC1 will learn about those prefixes, which in turn will advertise it to the existing edge, and the edge will then advertise it to the ISPs and hence the internet. So this was the setup. Okay for me to continue? We want to ask something here?
Yeah, go ahead.
So this was the end design of how things will be. So this is again the final data center where everything will be moved to. You have the edge OSPF area 0 between the existing core and the edge, and then you have these new VXLAN routing and bridging capable devices. And there I created a tenant VRF. That is where I will move all the SVIs. So whatever SVIs were there on data center 1, they will become IRBs here. And then I just show that I also have OSPF between them. Once one OSPF between the VRFs, it's a separate area. So the area inside the VRF is a separate OSPF area. It will be a TNSSA area again, and there is separate OSPF area for the underlay. I do not show the TORs in this case, which is not too much relevant here. And one second.
The
So yeah,
tenant
this is
VRF on the new core in DC2, right?
Yes,
Okay.
the tenant VRF is in the new core in DC2, and the logistics of the migration are going to be, we shut down the layer 3 in the existing data center, and we bring it up here. They start advertising it to the core, and whatever prefixes are public will then be advertised to the edge via the existing OSPF between core and edge, and the prefixes will go to the.
By the way, for the audience, let's explain what OSPF underlay, OSPF overlay you are seeing on the topology between the tenant VRF. So OSPF underlay for the infrastructure they use to connect those devices. OSPF overlay on the other side between the tenant VRF, they are running also OSPF. And also the TNSSA you are seeing there, it means total NSSA. NSSA stands for not so stable area. So they just get default route with the total NSSA. It's similar to ISAS L1 when you have multi-layer ISS, multi-level ISS design. Continue, please.
Yeah, and for people who are more curious about details, one important detail I did not mention is, so what was the most important thing for the underlay to work was the VTEP connectivity. So the data center to VTEPs, which is every single routers, the loopback address is the VTEP address, was for them to be aware of these two VTEP addresses. So all I had to do was, and I use subnets for the VTEP addresses, all I had to do was on data center 1 core, create a static route saying the VTEP subnet in data center 2 go this way, and static route in data center 2 saying VTEP subnet for these two layer 2 gateway capable routers go this way. And that is how I had the underlay VTEP connectivity. Once I had that, like I said, I used IBGP for the overlay connectivity, and I made this new core router 1 and new core router 2 as my route reflector servers. That is how they learned about the EVPN NLRIs and provided the EVPN fabric. So before I move to the next material that I have created, let's talk a little bit about whatever things that I learned here. The biggest things that I really learned, because this was my second time doing EVPN VXLAN, I was more comfortable with EVPN VXLAN, but there were small things like I had to make sure that Jumbo MTU is enabled point-to-point circuits between the two new data centers. Not only that, because there were SVIs involved also, which I then found out because we was not getting enough throughput because of MTU mismatch. Not only I needed high MTU on the point-to-point links, I also needed high MTU on the SVI. So depending on whether you are using Arista or Nexus, what you might see in your environment might differ. And again, some devices are smart enough where they don't care about the MTU on the SVI. In my case, the MTU on the SVI was also important. So I learned small lessons like that. Then for the distribution that I mentioned that I had to use here, this was like Nexus 3K in my case. So here again, just setting the MTU on the interface was not enough. And because I do not work with 3Ks a lot and I do not have use cases to do jumbo frames everywhere, I learned that it needed QoS changes to enable jumbo frames, which one can easily look up, and it's like a couple of line of config to enable that. But because I was doing it for the first time, I learned while doing it that there were like small lessons here and there to enable the jumbo frame so that I get the proper throughput over the EVPN VXLAN fabric.
Okay.
So these were some lessons I learned.
So one question. So you said you had multi-vendor in this network, but core devices was Cisco, I think, right?
Core device in the DC2 was Cisco. Core device in DC1 was Arista.
Because I would ask why you didn't do this with the OTV, for example, this migration. Cisco's OTV, but in this case it wouldn't be possible. So they needed to choose a standard way because any proprietary mechanism wouldn't work, and OTV is good technology but proprietary, and that's why here they are choosing layer 2 VPN solution, which could, which they would use for this migration. What else it could be, by the way? It would be just layer 2 point-to-point VPN or VPLS. It could be. Why you choose in this case EVPN and VXLAN, not VPLS or Ethernet over MPLS, etc.? Let me ask this.
Yeah, there is a very simple answer to that. Like any place, we end up choosing tools and designs that we are familiar with. And because this was the second time I was going to use EVPN VXLAN, and even though we manage our own MPLS L3 VPN backbone, so we have expertise in that area, but it seemed much easier to implement using EVPN VXLAN without getting a provider in and then doing something like VPLS or trying to do our own VPLS. This seemed much better. And even if to compare between VPLS and then we would be talking about classic problems with VPLS and then loop prevention, and then VPLS will do learning via data plane versus EVPN doing the learning via control plane. So some theoretical answers to that question and some practical answers because of familiarity of technology made us decide EVPN VXLAN.
For the loop prevention or scalability, etc., I wouldn't accept for your network, but for being familiar, definitely is the case, and I got your point. Okay. So let's continue.
So this was the background of this migration is still in place. Things are consuming it. It's going well. So before I talk about the second environment where I got the opportunity to do EVPN VXLAN, the Greenfield deployment, the disaster recovery data center, I want to talk a little bit about Ansible and how I ended up using it. Because the main reason for this talk was only to share how I use EVPN VXLAN for an interesting use case which might be useful to others, and even if not useful, as an academic example would be a good thing. But the thing that I would, if more than anything, I want to share with the community is how Ansible came in handy. So I want to talk a little bit about that. So some background. Before doing these projects, I did a little bit of Ansible in the labs, and I'm not an expert by any means on network automation, but I have exposure to Python programming and so on, just so that you know where I was when I started this project. And like most network engineers, we are so busy with the day-to-day, and sometimes it's not always possible to make that transition to go like full throttle on automation. But in my particular case, what happened is the Greenfield deploy that I had to do start of last year, I had to set up 60 something towers and a bunch of other devices along with Edge with just two engineers. So it was me and this other engineer, and the other engineer was a newer guy in the team, and he had some other responsibilities also. So now overnight, I have to set up this Greenfield deployment where I have to provision 60 top of the rack switches, along with learning this entire new technology, EVPN VXLAN, what it does, and do it properly. So what I realized is without doing Ansible, it was not possible. Or like doing Ansible, just an example. You can use Norner or you can use some other tool or make your own scripts, whatever you want to use. But when you are doing provision at a scale like that, you are kind of forced to use some automation, because I think the biggest roadblock is we become so good at making entire data center configuration in notepad files and copying and pasting our configurations in bulk that we are always like, I can do this in 2 weeks. Why should I spend time on automation, or I don't have time on automation? But in my example, in my projects, I was kind of forced to do automation. And that's why even in this material, I give an example of, so in the Greenfield deploy and in the data center migration, we are using multi-homing between the towers and the servers, and we are using ESI. So ESI again in the EVPN uses type 4 routes and type 1 routes for the ESI functionality. But you have like a port channel which ends up looking like this on Juniper to give you a trunk port over a port channel. So, and you have to create ESI IDs, Ethernet segment identifier IDs like this. Now imagine you are creating hundreds of these port channels, putting VLANs on them. And if you start putting this by hand, doesn't matter how good or how much expert we think we are, with bulk configuration. And I know most of us are really good at that because we have done that for years. But when you do it at a scale and you have to do it overnight, and at the same time, it's not only the initial deploy. Think about the constant provisioning. So you deploy a Greenfield data center, but now your sysops team, your data center team will add more racks, will add more servers. So for example, in the Greenfield deploy, out of 40 racks, 30 something racks were ready. 10 racks were going to come at a later time with the power. So now with each time new top of the racks being added, new servers being added, if we do not use an automation tool like this, you can imagine the number of network resources from an employee point of view you will need, and also the amount of time that we as good network engineers end up spending just provisioning things that we don't want to be doing. So let's talk about now Ansible in detail. This I just give rough snippets here because to give an idea, you obviously need to install Python. Ansible is Python based. Then you need to install the Ansible library. And in my case, because the devices that I was working with was Juniper, I had to install the Juniper EasyNC library for Ansible to work with. And once you have the basic installation, you define a simple inventory file like this. And I just show an example here where I say, these are my top of the rack switches, TOR1, TOR2, TOR3. These are my route reflectors or core switches, like the data center example, migration example, and these are the names. And then you have this structure called host variables. In the host variable, you use YAML files. YAML is a way of data modeling. It might look daunting to start with, but it is not bad once you get used to it. So this YAML file will define how I want TOR1 to be. So where I define things like the management IP on that, the loopback IP, which is the VTEP IP, what are the layer 3 links it is connected to, what are those devices called, so I can put proper description there. I was using /31s everywhere for my layer 3. So these are the IPs on the /31. If they do ESI, this is the LSCP ID between the two TORs. These are the bundles. These are the different VLANs. These are the description on the interfaces and so on. And this is all custom to my deploy. Depending on what you are doing, what your deploy looks like, what your conventions are, your files will look drastically different. And after you define the inventory, after you define the host files for various devices that you manage, you then have options for what is called group variables. So now think about group variables like common things between every single TOR in my data center. So one of the most common things that we can all think about is VLANs. So in my group variables, I had a file called tor.yaml, again a YAML file, where I will define the list of VLANs. I'm just showing a small example here. You can have hundreds of VLANs, give them meaningful names. And then I came up with a construct called VLAN set. Here I say, if a server is a database server, it is going to be an access port and it only needs VLAN 10. Same thing for mail server. But what if I have a web server? I want it to be a trunk port. So I define this trunk equal to yes for a variable. And then I say, these are the VLANs, and this is the native VLAN for the trunk port. Just to give an idea of the various combinations and things that are possible. And then you run your Ansible playbook. Playbook is what you tell Ansible to do with all this information and run against your device. And in my case, it was possible to do it over SSH. It was possible to do it over netconf. And after the initial TOR was configured, I would typically do it over netconf. So how do you go from these YAML files to an end result like this properly clean looking port channel or ether channel output? Is the secret glue that connects it. These are the Jinja 2 templates. So again, they might look a little bit daunting right now if you're not used to them, but they are not very crazy. You do need some Python understanding. So Jinja 2 template is where the business logic sits. So for example, when I define these VLANs, I need to write in my Jinja 2 template to grab these VLANs from the group variables and create the VLANs on the TORs. And similarly, I define these are the port channels here. These are the actual physical ports which will be part of the port channels. So all the translation happens in this Jinja 2 template. And here also, I just give small example of what the Jinja 2 template looks like. This is not everything that I was using. If we concentrate only on this bottom example, all I'm doing is I'm grabbing the list of VLANs and then I'm creating VNI based on it. So and this is my convention. You can use whatever. So if VLAN 10, I would make VNI for it 10,010. And I cannot stress enough that whatever I am describing about automation, it cannot be done properly without standardization. Standardization is big key. Even before you embark on something like this for a greenfield or for an existing data center, you need to standardize what subnet you will use for the loopback addresses, what you would use for your layer 3 links. You need to standardize with your data center team. For example, we standardize that the last 10 ports will be used for IPMI or iDRAG or whatever, or this port will be used for our PDUs, so that our PDUs are IP based also, so you can turn off and on servers remotely. But just example, where we said these ports will be used for this application. If you do not standardize things like this, even with automation, you will not have good looking automation solution, because before automation, and even this is not just network people are doing it, systems people are doing it for some time. Without standardization, what we end up having is called like a snowflake network. Snowflake network because it depends on who the operator is and how he or she has configured things. The end result will look different. So standardization is big here. So this is what I wanted to talk about from the Ansible point of view. Orhan, do you want to ask anything before I move to the Greenfield deploy?
Go ahead, please. No.
So now the Greenfield deploy, like I said, I did not architect this. We had an architect in my team who decided to leave last year, one of the very best network engineers I've ever worked with. He came with this Greenfield deploy where we have suddenly this data center with 40 racks, 4 different rows, and he had the requirements of how many server ports. He came with the design. I did the implementation. This is again all Juniper based. So we had a whole lot of servers. We had 60 something TORs. Every rack had 2 TORs, and these were copper port TORs, 48 ports, and these were layer 2 gateway. The reason why they were layer 2 gateway is because the form factor that we needed from Juniper was, this is QFX 5100, was only layer 2 gateway compatible, which worked out well for us because we wanted a centralized design anyways. So our EORs is where our VRFs in layer 3 was, and they were doing Anycast gateways there. And these are QFX 10002 devices. So we had 40 gig between the TORs and the EORs. And then we had our spine layer, and we had 100 gig between the EOR and the spines. And then 100 gig between our edge and spine. Even our ISPs are 100 gig. Bunch of MXs here for PE routers. They're not relevant for our VXLAN EVPN discussion, but I'm showing there for full disclosure of what the environment looked like. And this environment, we had EBGP for underlay, IBGP for overlay, spine 1 and spine 2 were RRs, different cluster ID, regular IBGP between them. That was the RR design. And I had other data center coming in via firewall and IPsec between them. And I had peering between the firewall and the EORs that you see here inside the WRF. And this is where I was using the Type 5 EVPN routes. So a little bit about the Type 5 EVPN route, and I put this intentionally there because EVPN VXLAN, for all intents and purposes, it's a L2 VPN technology. But with the Type 5 EVPN route type, we get the option to do something closer to an L3 VPN there. But think about Type 5 EVPN more like an IP WRF to IP WRF communication. And we can talk more about that if time permits. So here, TORs was all layer 3 EBGP to the EORs, and the EORs to spine was again all EBGP, and then, like I said, IBGP overlay on top of it. So this was the Greenfield data center.
Anuj, this is DC2, right?
This is the second use case that I mentioned in the beginning. This was the first EVPN VXLAN project that I worked on, was completely greenfield. Every single thing was new here. And
okay, this is completely separate topic than the one which we already discussed. Yes. Okay, good.
Yes. Yeah.
And this is single data center, not multi data center. This is single data center, EVPN, VXLAN. Okay.
Yes. So yeah, here again, all the multi-homing to the servers was done with ESIs there, no peer link needed between the TORs, multiple WRFs on the EORs. for separation between the public north-south communication and private communication. And between the private WRF and the firewall, like I said, I had a regular EBGP peering, and whatever prefixes I learned from the firewall, I injected them as type 5 VPN so that, for example, EOR3 for that particular WRF can talk to things behind this firewall by using type 5 between EOR2 and EOR3. So this gave me the flexibility, saying if tomorrow I need more EORs here based on a number of, if I run out of ports, I do not have to keep peering my firewall with every single EOR inside every single WRF. You can just pair with 2 of them for redundancy, and then these 2 will inject type 5 routes, which the other EORs will use to communicate for things behind the firewall.
Cool.
And the spine routers were not VTEPs, they were just underlay devices giving 100 gig port density, and they were used purely for underlay. So this was more textbook EVPN VXLAN.
Okay. So anything else? Otherwise, let's summarize a little bit fast.
That's it from my point of view.
Excellent. So by the way, maybe this Greenfield one we can deep dive later on for with another session by maybe introducing some low-level detail of the topology. Guys, if you have any question, please go ahead and use your microphone. You can ask. Otherwise, we will finish the session. We have some live audience at the moment. Any question? I think we are good. So you can, by the way, follow us on, I think Anuj is not using social media, but you can follow me on LinkedIn, Orhan Ergun, you can find. And we have a couple other videos for the data center design, real-life data center design on our YouTube channel. Please don't forget to subscribe to the YouTube channel. And if you find this video useful, write your comment, and we will continue real-life design discussion series with different engineers. With Anuj also, we can talk about this Greenfield deploy especially. I would like to hear more on that. And if you have any question also using Ansible here for the automation, you can type on the under the YouTube channel, on the YouTube video, I mean. And thanks for watching. And Anuj, what else you would like to say?
The only thing that I'd like to add is whatever I described about Ansible was very high level.
You can enable your camera at the moment. You can enable your camera. It's better. Let them see.
Yeah, the only thing that I like to add about the Ansible and the automation part is start with the hello world. So people who are not programmers do not know what hello world is. Maybe they don't know, but every single programming language, whatever you learn, starts with a hello world, which means like start with like baby steps there. And Ansible also, you do not have to build what I have built here from day one. And even I am only scratching the surface. To give you an idea, the next thing that I want to do is like automated validation, right? So we as network engineers do a lot of changes. We do CMs, MRs, whatever process we have, internally communicate and make changes, and then we manually verify. But you can add automated validation where you can use things like PyTest or even Ansible, so that end of every change you can things like, did I lose the underlay? Is it still working? Is the overlay still working? Is my connectivity to ISP still good? Am I still learning this many type 2s, for example? Is the type 5 peering still good? So on and so forth. So that is something I want to do next, and I would say you also should look into automated validation, which will be the next step.
Okay, excellent. And guys, as I said, second time, let me repeat, like or comment the video if you like this, if you found it useful. And we will continue the real life discussion series. And bye for now.